we have to start our last section of content before you have a test. All right, so we did a bunch of operations on fractions. Just we'll review it again, kind of go over like the step-by-step, like the step-by-step sort of instructions and things that you have to do. I'll try to get you guys your quiz back shortly. I'm just about done grading them, but people still need to take them. So everything that we've done with simplifying has to now be used to solve, right? Because when you are trying to solve equations, a lot of the same type of restriction information or factoring, all of that kind of stuff comes back into play with solving rationals. So we're going to start from something small and work our way up. So we're going to have multiple days before you have to review for your test. Right. So for the first thing, before we even actually start solving any equations, you have to think about common denominators. So I want to first just be able to find the least common multiple of the denominators. Because you can't really do anything in terms of solving until you can figure out what the denominators look like and how you're going to find the smallest one to fraction bust. And that's really what we're going to do, is we're trying to fraction bust. So this is kind of just like the setup, like the beginning of it. And so here is just a string of terms. We're just going to separate them by commas. I'm not going to put any like plus or minuses, no equations. I'm just going to list out what the individual terms would be, so that way I can focus solely on their denominators and figure out what my LCD would be. All right. So when you look at it, you have to look at the fact that these are all monomial factors. All right. They have multiple factors in them, but they're still monomials. You don't have any like parentheses separating with addition and subtraction. So on something like this, for your least common denominator, you have to have a factor of 2, otherwise you're not going to be able to fraction bust the 2. You also need to be able to have an n squared, so that way if I were to multiply every single one of these fractions together, I would get rid of any 2 that's in the denominator and any of the n squareds. And you should have nothing left in the denominators if I were to fraction bust this. You also don't want to have too much. Like if you use everything that you see, you're going to be multiplying by way, way more factors than you need. And you're going to end up creating numerators that are monstrously big that are unnecessary. So you want the smallest denominator possible that would get rid of everything. All right, so here are 2 other fractions. And the ones that I'm giving you are ones that are common when we start actually creating equations to solve. All right, so now you've got a denominator that has more than one term to it. So you have to factor this. All right, you can't just, you have to remember, you can't just add something to this part. The first thing you have to do is factor this denominator so you can see what the individual factors are supposed to be. All right, because in the first fraction you've got a monomial factor of x, but a binomial factor of x plus 2. So when you're writing down what your common denominator is going to be, right, if I look at just the monomials first, this one has a singular x, and this one has an x squared, so I need the highest power. I need to be able to use in the monomials both x's. And then I also need this binomial factor of x plus 2. We're not going to multiply out the denominator. You're going to leave it like that so that way you can see what is missing in each fraction to make it look like this, all right, or what I would be having in terms of multiplying what's left. So you don't want to multiply this through and do an x cubed plus 2x squared. That's going to make things way harder on you. You don't want to do it. All right? But you do need to consider your monomials and your binomials as separate factors. So doing this kind of factoring right here is going to be important. All right, so when you see 2 or 3 terms in the denominator, you are going to have to factor. However that is, whether it's just a GCF, difference of squares, whatever the case may be. And then your last one we're going to look at looks like this. So you've got one fraction. That's the 1 over r minus 2. Again, that's contained together. Right? And then you've got the other fraction where you've got 3 terms. So you can just put parentheses around this one as your binomial factor of that denominator. There's nothing you could factor out or any way to change that. But you do need to factor this one. And so if you kind of think about, you're looking for two numbers where the product is 10 and the sum is negative 7. You can use negative 2, negative 5. And so again, you got to factor this. However your skills are for your factoring for a 3-term denominator, you're going to have to do that. And so this one has binomial factors on both. So my common denominator, I'm going to need both the r minus 2 and the r minus 5. But I don't need anything extra from the first fraction. Looking at your bigger fraction, if it has all of the factors that are needed, you don't have to add anything extra. It's already there. And so part of the work that we're going to do is just straight up just this. Right? What would be the common denominators? Because until you can find that, it doesn't really do you any good to keep moving on. All right, so let me get you the steps, because that's going to be important. So steps to solving. All right, it's going to be kind of like, what do we do first, second, third, that kind of thing. And then we'll do a couple. All right, so the first thing that you have to be able to do is, when you're looking at these denominators, exactly like I was doing, you got to be able to factor. All right, so you want to factor all 2- and 3-term denominators. So factor all denominators with 2 or 3 terms. If it just has a monomial, you don't have to think about it factoring that. You just have to look at what the factors are, but if it has more than one term in it, you're going to have to do something else. So then you have to remember what your options are with 2- and 3-term denominators. All right? So when you have 2 terms, your main 2 options are either just taking out a GCF or a difference of squares. Right. So with the GCF, that would be something like the letter B. That would be one like when you had x squared plus 2x, that the only thing I can do is take out the x that they have in common and write it as a binomial and a monomial factor combo. Right. That's one option. Right. I said the other option is difference of squares. And those are ones where you have the 2 terms where you have a perfect square minus a perfect square, like c squared minus 4. Right? Where there is no GCF, right? There's nothing I can do by taking out something I have in common, but I can factor this as a c plus 2 and a c minus 2. So when you have 2 terms, those are the most common type of options. Your other types are also down when you have the 3 terms. And those are the ones like letter C, right? Like where you want to be able to just use the product sum. So like the r squared minus 7r plus 10. All right, ones that you could factor really quickly because your a value is equal to 1. So any of the ones where you see 3 terms in the bottom and your a is equal to 1, you can just do the product sum, that quick method. You don't have to do an area box for that. But you will have to think about using some sort of area box or factoring by grouping if you had something like 2x squared minus 5x plus 3 in the denominator. Because that does not have an a equal to 1. So you can't just look at product sum and create the 2 binomials really quickly. So if you have to go off to the side and do an area box, you need to make sure that when you factor this, it ends up looking like 2 binomials that if I were to multiply them back through again would actually give me that trinomial. All right, so one of these is going to have a 2 somewhere in the first term. Again, you can find that by going and using an area box or something. All right. Like whatever you need to do if that's how you like to factor those. All right, that's how I like to factor them. All right, so once you get to factoring all of your denominators, that's just like the first step. All right, so like you can see it does sometimes doesn't take you very long, but I want to give you like your list of most common options. All right, the second thing you have to figure out is you have to find your LCD. All right, you have to figure out based off of all of those factors in the denominators what's going to be the least common denominator you're going to use to fraction bust. And we haven't done it yet because we haven't started solving anything, but you need to identify your restrictions. So your restrictions, things that were a restriction before, are now going to be called extraneous solutions. They are still restrictions, but because you're solving for something, we call it a different name. All right. There are still values that you are not allowed to use because they will make the denominator 0. All right, and that's why they're called extraneous. They're pretty much they're extra values that you're not allowed to have. All right, but on a lot of the work we do, they're called extraneous instead of restrictions. All right. Let's see, what else do I have? Oh, yep. So now you got a fraction bust. All right, so you're going to multiply all terms by the LCD. All right, so once you multiply all the terms by the LCD, now you have to simplify the numerators and do what you got to do. So you're going to be multiplying, simplifying, and combining like terms. And when you do that, once you do all your multiplying, all right, now you're just going to solve whatever's left. Whatever the variable is, it's either going to be something linear or something quadratic, but you're going to have to solve the whatever equation is left and throw away any values that were one of your extraneous solutions. All right, so now you're just going to solve. Again, it's going to end up being something linear or quadratic. And you're going to throw away extraneous solutions. Let's call them ES, so you don't have to write the word all over again. So it looks like a lot of steps, and it kind of is. These are going to take a lot longer than pretty much anything else we've done so far in this module.